everyone, so now we're going to be recording our vertical and horizontal angles. So you need to have your needed material out and ready to go because you'll be starting with your map. So here I have a Hilo Bay nautical map. And here it is, and we're going to be looking up here at Honolulu Beach Park for the data that I've collected there previously. But I'll show you how to collect that data, but we're just going to be using the data that I collected the other day. So you have your map, and then you have your calculator, your pen, pencil, eraser, tape measure, and your compass, as well as your triangle ruler and a regular ruler. So you'll start with using your nautical map to find your field of study, which will be Honolulu Beach Park at the top. And you want to find your elevation and latitude and longitude of where the theodolite is set up. For more precise measures, you could use like a compass app, which says your exact elevation and your coordinates. So today I've used that, and I actually have a point of where we are on the map of where the theodolite is. And I know that our elevation is 70 feet at Honolulu Beach Park. You'll then want to record this value under which I left blanks for theodolite elevation and your latitude and longitude. You'll then chart the theodolite coordinates, which I put on there, but basically you'll want to look on the sides, take your coordinates, use your two different rulers to make a line at each point so you can find where you're at. Take your tape measure in inches and record the height of the theodolite because that's part of the elevation. So on the thought side, it's kind of a good point because you're looking through it right at this level. So I'll line up the tape measure. Looks like we're at 56 inches. So we are going to write 56 on our paper, where there is a blank. You're then going to want to convert those inches into feet with the conversion factor, which is on the paper. So I'll take 56, I'll write that 56 in, and then I'll divide it by 12. And ideally you want to take 3 decimal places because you're going to be doing various calculations and you don't want to calculate it to just 1 decimal place and then be off. So better just to do more. So it looks like we have 4.666, and then we're going to add the elevation on the nautical map, which is the 70, to my feet of the theodolite. So I'll put the 56, or I'll put the 70 feet, and I'll add that to the 4.666, which will have 74.666. Now we're going to locate our reference point, which would be a distinct feature along your shoreline. So we're looking this way, this is our ocean. We're just going to kind of pretend that this is, we are, let's say, we're here, this is the theodolite. And then we have our reference point here. We're going to say that's the cliff at Honolulu Beach Park, because when you're looking from the parking lot, you look out at the ocean, and to your left, there's that cliff that jets out, and there's the house on top. So you can use that. So that'll be our cliff point, but ideally reference point. Now, this reference point can be anything along your coastline. I could have chosen, let's say, if there was a tree over here, or if there was some rocks down here. Ideally, it just needs to be in your eye line off the coast. But today we'll use that cliff. And keep in mind too, when you're choosing a reference point, It has to be a point where you're able to you're able to find it on your nautical map and find its elevation as well as your distance from it. So on my map, it looks like the elevation is 50. So we're gonna write 50 in the spot below. You're gonna want to find your true degrees from the theodolite with the compass rose on the map. So you'll line up the triangle from your theodolite to your reference point on the map. So I will line it up, and you're going to use your other ruler as well. So you'll line up the points, you'll take the other ruler, you'll slide it over to your compass rose, which is the purple in the middle of the map. And we're going to be looking at the outer circle, which is the true degrees, because magnetic is on the inside. So I have it matched up, and it looks like we're at 22. You're going to write that on the next page. Now, I'm going to put on the battery pack, turn it, and the battery pack comes off. This is the refillable one for actual batteries, but today we're just going to be using the rechargeable one. And here's the charger that it comes with as well, which I've already charged it in advance. So we're now going to place that on as you took the other one off, and then lock it into place. So we're going to want to look at the theodolite where the tubular vial is facing towards us, which is at the top here. So I'm going to have it facing towards me, and you're going to press and hold the on and off orange button. And you're going to hear this beeping and the display, and once you hear the beeping and see the display, you can release it and it will turn on. Okay, there we go. And then every time you turn it on, you'll always see the vertical and the horizontal angle. So we have, though it says Seto 0 here, it always says this as the start. You have to move your telescope here down towards the ocean to have it start recording, but we're just going to hold off for a second on that. And then we have our horizontal angle reading here. And right now, it does say that it's HR, which means that if we turn it to the right, it's going to increase, but if we turn it to the left, it's going to decrease. And that has to do with once we're like set in our reference point and going towards the ocean. Rotate the telescope out towards our ocean and take off the lens cap. And we're going to rotate it all the way down. And as you see, it's going to start to record a vertical angle. You want to look through to focus the background that you're seeing as well as the crosshairs. So I will do that at the whiteboard. Made the back clear, I've focused the crosshairs, and I'm on my reference point. At this point, you're going to want to use the vertical and the horizontal clamp, which is on this other side, and it's the bigger part that's closer to the theodolite. So you'll start with the horizontal one, and you'll lock it into place, and then you'll lock the vertical one into place, and then you're going to want to use the fine motion screws, which are the outer parts, to move it up or down, or side to side, to focus on your reference point. And then once you're on your point, you are now going to think about whether you're going to be turning like your reference point either to your left or to your right. So today it's to my left. So I will then be turning the theodolite to the right. So we want HR to be on. But let's say we had a reference point, over here, and then you're moving towards the ocean. Let's say the ocean's like here. You want to have it as HL. So at this point, you would decide which is which. So right now we're in HR. We're going to turn to the right, so it's going to increase as we're moving. So we're going to keep it the same. But if you are doing this right now and you're going to be moving to the left, switch that now, and you'll do that by pressing the button on the screen. It says R/L. You just press that, it switches it. Press the offset button, which zeroes out your horizontal angle. You're now going to record your vertical angle. And so on the worksheet here, I've already recorded the vertical angle that I had at Honolulu. We're just gonna use that, but usually in normal situations, you would record the vertical angle under vertical angle 1. You're now gonna release the vertical clamp, which is this one. And then you're gonna release the horizontal clamp, which is down below. And now your horizontal angle might have increased or decreased. You can know it decreased if it went to like 359. It means like you've fully rotated. It just means it's slightly turned to the left of your reference point, but that's okay. We zeroed it out on a reference point, so we're just gonna turn it to the right, out to the ocean, and it's gonna increase with us. And the vertical angle is just gonna change as we move this up and down. And now you're gonna look for a whale or a dolphin, or our whale, let's say, is right here. So we'll say that's our whale. So once you have it focused on your whale, don't worry about the horizontal and vertical clamps. It's very hard to find your whale and then turn them, and then you're off your whale. And with the fine motion adjustment screws, you can't move it that quickly back onto your whale. That's moving. So once you spot it, you're like, okay, I saw it there. You're gonna wanna record your vertical angle 2, which will just be the new vertical angle you have here, and then your first horizontal angle. But today, once again, I wrote the ones that I got at Honolulu. Now you're gonna repeat these steps, 69 through 70, to record multiple angles for that mammal. And once you have the angles collected, you can then turn off the Theodolite. Basically, when recording more points, you started at the same reference point. So let's say you took a recording of this whale, and then let's say it's moving this way, and then you spotted it here again, and then let's say it's moving down, and you spotted it there. So you recorded the vertical 2, and another horizontal, just another vertical and horizontal angle, and then another one here. And you'll basically, in the next part, you're gonna be calculating the latitude and longitude. You'll end up finding that. And you can kind of do that process with each of these points. But let's say you lose contact of this animal, and let's say you just got a second point for the animal, and you can't find it now. You can continue, and you can mark this as whale 1. And let's say, oh, I see a dolphin here. You can mark that as your dolphin 1, and then let's say, oh, it's moving this way. And you collect a point here, your vertical and horizontal. And you kind of do the same process. You can chart multiple whales from that first reference back onto the map and your manual to then calculate further points for the next section, which is latitude and longitude.